what I want to do is, because you can see how short the notes are, right? So I want to just go to these, these two diagrams. Now, which one of these, okay, let's graph this one here. So we're going to do, this is going to be this one. So just write it underneath. Y is greater or equal to x squared minus 3x minus 4. Now just out of just your own intuition, how can you, that means greater, means above, right? How can you shade above this thing? Like if you shaded here, would that be above? Like you're not above it, right? There's no way, you're still underneath the graph. So this would be the answer to that. And it's greater or equal to, isn't it? Because it is a solid line. Does that make sense? Now, I want to pick a test point. Okay, this might even be on your test. So any point on here, I want to test it to see if this is true that I have picked the right one. This point right here is 0.11. That is in my area, isn't it? Let's try 1 out. So here's my equation. Y is greater or equal to x squared minus 3x minus 4. I want to see if this is true. If I put 1 in there, this statement should be true. 1 is greater or equal to 1 squared minus 3 times 1 minus 4. 1 is supposed to be greater than 1 minus 3 minus 4. 1 is greater or equal to, what would that be, negative 6? Is that a true statement? Yeah, so you know you picked it right. Okay? Now, let's try this one over here. If I was to shade this, this is underneath. This is less than. So this would be y is less than or equal to x squared minus 3x minus 4. Now, test point. Let's test 5, over here. Do you see 5, 0? It's not, it's in our area, isn't it? It should work when I try it. So 5, 0. 0 is the y, right? So let's test 5, 0. 0 is supposed to be less than or equal to 5 squared minus 3 times 5 minus 4. 0 is less than 25 minus 15 minus 4. 0 is less than or equal to 25 minus 15 is 10. 10 minus 4 is 6. Is 0 less than 6? Yes. Okay? So it might be a question that would say, which would be a test point that would prove this? And you have obviously an infinite amount, but it would be a multiple choice, right? And they would list 4 of them. Only one of them would be in this shaded area. Okay? Simple? Okay, now we're going to hold on. Okay, let's go to the next one. So we haven't used our graphing calculators yet, right? Now, the kind of, I guess, things to know, if the test point does satisfy the inequality, shade that region, okay? Now, often I shade the region and then test it, but whatever, it doesn't matter. So just make sure if you're greater than or greater than equal, you're shading. Now, if this was the equation or the graph, I would shade like this, right? What if the graph went like this? You see how I'd be shading this, right? Does that make sense? See how I'm still above the graph? And I guess make sure we know that it's dotted and okay, and then less than would be the opposite. You're under the graph. Okay, let's do this question below. It says shade the solution y is less than 20 minus, or 20 plus x minus x squared. So we're going to do this totally without a calculator. Now, this might make more sense. Y is less than negative x squared plus x plus 20. All I did was get in the right order. Now, because there's a negative 1 here, we actually got to do what two things add to 1, because there's a 1 here, and multiply to negative 20. What are they? So negative 5 and 4. 5 and negative 4. Okay, so we just can't go x plus 5, x minus 4, because this is a type 2. There's a so this is y is less than negative 1x plus 5x minus 4x plus 20. Right, we have to do this the long way because a is not 1. Then we'll put my brackets here, and I will go y is less than, take out a negative 1, x plus 5, or sorry, and a 1x, x plus 5, and take out a, what did I take out of here? Oh, that's x minus 5, sorry. I will take out a negative 4, x minus 5. Okay, so y is less than x minus 5 and negative x minus 4. Okay, now, what is the zeros? Negative 5 and negative 4? Or 5? 5 and negative 4. Okay? So here's negative 4. And here is 5. Now, is this going up or down? It's going down, isn't it? Because of the negative. It's going down. Okay, so without getting too fancy, it would be something like this. Okay, where is the shading? Oop. Okay, inside, and I can't have solid, can I? Okay, so we should be shading here. Okay, give me a test value. I need to test with 1 point. 0, 0, be good to yourself, right? Why pick negative 2.73 and 15.2, right? So 0, 0, test it. Now go into the original. So 0 is supposed to be less than 20 plus 0 minus 0 squared. Is 0 less than 20? Yes. So your point 0, 0, your test, it did work. Now we're not going to worry too much about the vertex at this point. We're going to kind of talk about that more tomorrow. But getting, you know, your x ints, obviously to put it, you know it's going down. Remember, if it's positive y equals positive ax squared, it's going to be going up. If y equals negative ax squared, it's always going to be going down. So you know it's going down. You know it had a x-intercepts of negative 4 and 5, so you can rough that. This we can leave as kind of arbitrary here. Okay, we'll get more into, because we know how to find vertexes with x minus p squared plus q. We're going to do more of that tomorrow. Okay, so except for the shading, not much is new here. Okay, so we're doing 1 to 6.